Okay, this is the P4 paper from October 2021. Question number 3. There's a little bit partial fractions in here. There's some differentiation in here, but it's quite an unusual question. Let's make a start on it. It says gx is given by 3x cubed plus 8x squared minus 3x minus 6 all divided by x plus 3. But that's identical to ax plus b plus c over x plus d over x plus 3. And they're asking us to work out the values of the constants a, b, c, and d. So the way that I'm going to do this one is, to say if I set out 3x cubed, what was it, 3x cubed plus 8x squared minus 3x minus 6, well, I'm actually just going to do the long division. That divided by x squared plus 3x and see what we get. So if we want to do algebraic long division, how many times does x squared go into 3x cubed? It goes in 3x times. If I now multiply 3x by all of that, I'm going to get 3x cubed plus 9x squared. And what I now do is subtract that to see what I've got left over. 8x squared minus 9x squared is minus x squared. Bring down the minus 3x minus 6. And now repeat the process. How many times does x squared go into minus x squared this time? Okay, well that goes in minus 1 times. Minus 1 now multiplied by all of this is going to give me minus x squared minus 3x. And if we now subtract that away, we're actually going to get that both of those cancel. We'll just end up with minus 6. So what that tells me at the moment is that if I do that division, I get, so in fact, let's just show it. If I do 3x cubed plus 8x squared minus 3x minus 6 all divided by x squared plus 3x, in other words, xx plus 3, which is what we had. This part is the quotient, 3x minus 1 is the multiplier. And what are we left with? We're left with minus 6 as a remainder, and it's minus 6 out of x plus 3. So if I go and look at what we had there, then I've got my ax plus b. This bit now needs to be tidied up to make c over x and d over x plus 3. So if I want to do that, be careful about that minus sign. Okay, we'll have to put that back in later on, but all I'm going to do is I'm now going to say 6 over x plus 3. What's that if I write it down as a partial fraction? If I split it up into partial fractions, it's a over x plus b over x plus 3, and this is just our classic standard partial fractions now. So we say ax plus 3, bx all over x plus 3 is equal to 6 over x plus 3. Let's just compare the top lines, compare the numerators. So I'm going to get that 6 equals a x plus 3 plus bx. I hope you're very comfortable with doing this work. I need to get rid of the a and get rid of the b. I'm going to get rid of the b first of all by setting x equals 0. If I set x equals 0, I'll get a, or rather 3a equals 6. So a is 2. If now I set x to be equal to minus 3 this time, that'll get rid of the a. I'm going to get 6 is equal to, the a's go, so just minus 3b. So b is equal to minus 2. So what I can now do is I can say that 6 over x plus 3 is equal to a over x, which is 2 over x, plus b over x, which is minus 2 over x plus 3. So if I now put this information into this part here, I'm going to get that the original question, gx is equal to 3x minus 1, and then it's minus this thing, so minus 2 over x plus 2 over x plus 3. Let's just tidy that up a little bit. So there we go. There's our A, B, and C. Sorry, A, B, C, and D for our first part. Completed right there. Fantastic. So part B. If gx is this, 3x minus 1 minus 2, I'm going to call that x to the minus 1. I'm going to call that plus 2 x plus 3 to the minus 1, simply because for part B, I need to differentiate it. So if I'm going to differentiate this, differentiating 3x is 3, differentiating the 1 disappears. Remember, you're multiplying by the power, taking 1 off the power. So multiplying by minus 1 makes plus 2 x to the minus 2. And the same with 2 over x, or 2x plus 3 to the minus 1, or 2 over x plus 3. We can do it quickly. Hopefully, this is P4, isn't it, by now? So multiply by the power, take 1 off the power, multiply by the differential of what's in there, but the differential of what's in there is just 1. So that's the answer to g-x. We won't do any more of that. Let's just go back and check. They just said find it. They didn't say anything in particular about it. And then this part C is, a little bit unusual. You need to have seen this style of question. Explain why g-x is greater than 3 for all values in the domain. So what we're saying is that g-x is equal, g-x is equal to 3 plus 2x to the minus 2. Minus 2x plus 3 to the minus 2. But if we're saying that this is greater than 3, then what we're actually saying is that the 2x to the minus 2 over x plus 3 to the minus 2, we're saying that that has to be greater than 0 then, don't we? They can just cancel out here, okay? Which gives me, if I write these properly now, 2 over x squared minus 2 over x plus 3 squared has to be greater than 0. Or in other words, 2 over x squared has to be greater than 2 over x plus 3 squared. Now we could do quite a bit of extra work here, but this is only, is this worth 1 mark? Where are we? Yeah, it's only worth 1 mark there. So you think, I don't want to be doing much more than this. And actually this is just by looking at it now, okay? Simply because of the function that we got here. 2 over something squared and 2 over something squared are pretty much similar to each other. And if you actually look at them then, if this is x squared and this is x plus 3 squared, then that is always going to be true. This value basically always has to be bigger than this value, which means then that the fractions will be the other way around. So if you're quick enough to be able to say that, you can say this is always true, which is always true for all x. So interesting little one there, all x greater than 0, obviously. And yeah, that's a nasty little 1 marker there. You don't spend too long actually just looking at it to see. So I said that x was greater than 0 there. Yeah, just be careful of that last little bit there, and not, if you're thinking about your exam craft now, don't spend ages